Welcome to solverfy.
Okay, so here for problem 26, we're given two 2x2 matrices. A, which is equal to 1, 1, 0, 1, and B being equal to 0, 1, 1, 0. So for part A, we want to find A or B, okay? And so with these matrices, what's going to happen is the first element, much like when we add, we're taking each ijth corresponding element, right? So we'll put it into this sort of equation. So we'll say 1 or 0. And we'll do the same for the other corresponding elements, right? So then we'll get this 1 or 1, and then we get 0 or 1, and 1 or 0. Okay, and in this instance, the result is going to be equal to a 1 if either the element from A or the element from B is equal to 1. And so in this instance, we have a 1 in every pair. So the entire matrix is going to be 1s. Now when we go to B, which is sort of the AND operation, we're going to end up doing the same pairwise comparison. So we get the same matrix as above, but with a different operation that's happening to it, right? So we're getting the AND. And in this instance, it's going to be equal to a 1 when both elements are 1, right? So only when both are 1. Okay, so that only occurs in the upper right portion of the matrix, and then the rest end up being zeros because there's a 0 present in one of the two elements for both. Okay, then for C, I'm just going to rewrite our matrices above here. This is the 1, 1, 0, 1 for A, and B being 0, 1, 1, 0. Okay, then so for C, we want to take this last operation here, and in this instance, we get that the Boolean product is obtained similar to when we do a product of matrices, whereas for parts A and B, it was similar to when we take the sum, but where we are replacing addition with the OR operation and our multiplication with the AND operation, okay? So then what happens is we take, so our first row and first column, where we would normally multiply 1 and 0, instead we'll get the 1 and 0, right? But then we would add that to a 1, which would be normally multiplied by a 1, but instead we're taking the Boolean AND, so we get 1 and 1. Okay, we repeat the process, right? So we'd say the same row, but a new column. So it's analogous to the taking the product, and this time we'll get a 1 and 1, or a 1 and 0. Okay, and then we'll repeat the process here for the next row of A, and that's going to give us 0 and 0, or 1 and 1. And then for the final row column pair, we get a 0 and 1, or a 0 and 0. Okay, and then this will get reduced. I should have not quite made the arm of my matrix so long here. Okay. So this will get reduced then to, we can sort of take care of what's happening in the brackets, right? So then we'll get a 0 or 1. Then we get a 1 or 0, 0 or 1, and a 0 or 0. And then solving this one, we get 1, 1, 1, 0, right? So anytime a 1 is present at all, we get a 1 in our final matrix.